Thank you. And from a data perspective, I'm told that my name is a unique identifier. So if you search for my name, everything that comes up will be related to me. So I've called my talk I'm also short. The name of our project, which is WeCount. And the project is located at the Inclusive Design Research Center, which is a center that I started back in 1993, so we're 30 years old. And our vision and mission is to make sure from the very beginning that emerging innovations work for everyone. And everything we do is open source, open access, open standards, open data, even before the term open data, I think was originally coined. And we have over 100 research partner organizations globally, and I have a graduate program as well in inclusive design, and we have an institute. And the project, WeCount, is a community-driven project to address inherent bias against small minorities and outliers in artificial intelligence and data analytics, making sure people with lived experience of disability can participate in shaping data science, addressing data gaps and biases, co-designing protections against data abuse and misuse, and co-creating more equitable decision supports is what we do. And lastly, one of the things we're working on at the moment is a disability-specific federal AI standard that will be a regulatory standard that's part of the Accessible Canada Act. But before I talk about all of these things, I want to give you a little bit of my backstory with AI. Back in the 80s, my first encounter with AI was to work on speech recognition using hidden Markov model for dysarthric speech. So people who could never use a standard speech recognition system to try to recognize repeatable utterances that they could make so they could communicate with people who were unfamiliar with their unusual speech. And we were able to reach a very, very high recognition rate for these individuals who would otherwise be using devices that would be very, very slow in typing or communicating. When I tried when I took that same data and retried it recently, we could not get any recognition because what had happened is AI had matured, and so those tiny pieces of data were fighting all of the pervading models, the big data that had now been incorporated in speech recognition. But my major alarm regarding AI and the issues with AI came in 2013 when I was asked to work with the Ontario Ministry of Transportation, which had its 100th anniversary, and they wanted to get input on automated vehicles. And so what I decided to do was to try out the automated vehicle learning models, and there were 7 of them, with a capture of a friend of mine who pushes her wheelchair backwards. It's very unexpected. When she's in an intersection, people will think that she's lost control. They'll grab her wheelchair and push her back where she came from. And lo and behold, all of the automated vehicle engines or automated vehicle systems decided to proceed through the intersection and thereby effectively running her over. They all said, don't worry, these are immature systems, they don't have enough data, they don't have data about people in wheelchairs and intersections. Come back when when they're more mature and they have more data. Can anybody tell me what happened when they had more data about people in wheelchairs and intersections? They chose to run her over with greater confidence because the data systems were sure that people in wheelchairs were probably going to go forward. And so the confidence level increased as the data increased. And that, of course, raised all sorts of alarms. Smarter is not always better. And this is in line with my data exercise over the last 40 years. I came into the field in '79, and since then I have had this research project where I ask people, what do you need to thrive and survive within a digital sphere? And we've used it in an ISO standard. We've got standard metadata, but the data set, of course, is hugely diverse. And the only way that I can plot it is in a multivariate scatter plot, a three-dimensional multivariate scatter plot, and I'm going to show you a terrible two-dimensional image of it, but I call it my human starburst. And what you'll notice there is that about 80%, like a normal distribution, 80% of the needs are clustered in 20% of the middle. The remaining 20% are scattered throughout the periphery and taking up 80% of the remaining space. And of import to accessibility and the groups that I work with is that the dots in the middle are very close together, meaning they're very similar. The dots, as you move away from, or the data elements, as you move away from the middle, get further and further apart, meaning they're more and more different. And one of the unfortunate things is that accessibility and disability has frequently been considered as sort of access for all, access, full accessibility with a particular checklist, which of course goes against, this goes against that. But more generally, what you'll find is because we generally adhere to the Pareto principle and we design things for the 80% majority and ignore the 20% that require 80% of the effort, because of economies of scale, because of all sorts of things, designs, whether it's policy, services, data sets, questions, metrics, measures, all of the things you use, products, seem to work for, or work fairly well if your needs are in the middle, get difficult to use as you transition from there, and people at the periphery cannot use the designs. And similarly, all of those data findings, because we're using statistical reasoning, tend to be highly accurate if you are characterized by those needs in the middle, and become inaccurate and actually are wrong as you get to the periphery. And this ripples through all of the parts of our life, whether it's the misfit or fit of design, whether it's Moore's law, which is increasing, which means that all of those digital products we're using are increasing in availability, reliability, functionality, and cost. But if your needs are out at that edge, as we heard this morning during the panel, the availability, reliability, functionality, and cost increases. The cost increases, the availability, reliability, and functionality gets worse. I'm an academic, I'm a professor, and one of the unfortunate things is that knowledge also follows the same pattern. How many people are able to publish, get tenure, get funding if what you're researching is somebody that is an outlier or where there's an n equals 1? And so the amount of knowledge regarding people that are out in the periphery is less and less. Education. We are doubling down on ranking students, on STEM subjects, on creating standardized learners, when in fact what we need is we need greater diversification of learning, replaceable workers. And if, especially as we now use productivity and surveillance tools to gather more data on what is a successful productive worker, that if you don't conform to those particular ways that it is measured or productivity is determined, then you're also out of luck. And even as we are doubling down on evidence-based governance by numbers, the trivial needs of the majority will outweigh the critical needs of the few. If all we're doing is defining democracy as one person, one vote. So this, of course, has horrible effects for that 20%, but it also creates risks for the rest of the population because of the way that we're treating design, the way that we're treating our tools, our systems. We have mass production, mass communication, mass marketing, a popularity push, and we are decreasing our opportunity to truly innovate because we have greater conformance, lock-in, decreased flexibility, extensibility, resilience, and responsiveness. And because we're creating segregated systems for people that don't fit that middle, we are also losing out on the innovation that comes from making all of our systems work better for everyone. Because if you design in such a way that you are addressing the needs out at that outer edge, everyone has room for change and growth. And lo and behold, where does most of the innovation, where do we detect the weak signals? It's not by those individuals that are well-served, complacent, and doing fine, thank you. It is the people that require change and the people that are most vulnerable to the risks to come. And one of the groups that we work primarily with is people with disabilities. And we define disability with a social model. So people who are sufficiently different from the average or the norm that systems don't work for them. And disability is a universal trait that is at the jagged edges of every other justice-deserving group. And if you have a disability, the opportunities, but also the risks are at the extremes. And there are many extreme opportunities. Recognizing speech, gestures, patterns, finding a target object or pattern using AI, matching or labeling objects, remembering forever and reminding on time. I'm supposed to be retired, so I can definitely use that. Sort possible paths to find the optimum, detect common mistakes and correct them. Those are all really, really useful things. They're all mechanizing a formulaic, and they're using data not about the person, but about the environment, which tends to be standard. But a less known risk of these is that, in essence, the way that we've designed AI is it has become an infrastructure of disability discrimination when we are finding, matching, sorting, labeling, measuring, optimizing, calculating, analyzing people at scale. We are reducing diversity, we're denying complexity, and we're homogenizing toward a monoculture. AI is mechanizing, accelerating, amplifying, and automating an existing problem. It's propagating discrimination faster, more efficiently, and more accurately. And the assumptions of pervasively deployed AI decision systems, and here I'm talking not about the emergent systems like ChatGPT or generative or large language models, but the systems that we have currently deployed in so many decisions that are impacting our life, is that past success equals future success, and optimizing data characteristics associated with past successes increases future successes. And the data characteristics that determine success need not be specified or known to the operators of the AI. But what we don't seem to realize is that bias toward an optimal patterns equals bias against difference. And AI is getting better or more accurate, and as it does, it's getting more discriminatory. The more granular the data that you're collecting, the more you fill out Microsoft Viva or whatever, the more likely it is that the ways to be different are increase. And so there is a greater increase in all of the discriminatory decisions that have been made. And this is pervasively deployed in employment to filter, say, 1,000, actually here at the university for admissions. Most jobs where most competitive jobs, actually it would have been great to have asked Google this, use AI to select the 10 that will be interviewed. The interviews are actually viewed by an AI to figure out, or the visual interviews are also determined and filtered by an AI. Medical calculators and triage tools were used during the pandemic, and one of the things that we've discovered is that as evidence-based medicine increases, so does iatrogenic death and illness. So the people that are unlike the average are dying more because of the mistreatment or the choice of treatments by an AI system. Policing and parole is using AI, immigration and refugee applications, tax auditors, loans, mortgage security flagging. We've just been working with CRA who have many more false positive audits if you have a disability. At a community level, evidence-based government investment, political platforms, determination of what should be the platform, public health decisions, urban planning, emergency preparedness, security measures, all of these are using some form of automated decision systems or guidance. And then there is the cumulative impact, those very trivial things that never come up in the risk assessment, never come up in the impact assessment, news coverage, products marketed, GPS routes, supply chain priority, design features selected by products which are consumer products. But if almost every decision, these trivial decisions, is made in a way that doesn't benefit you, then there is cumulative harm. And of course, there's been an exponential change. There is alarm. We've heard from Jeffrey Hinton and Bengio and everyone involved in AI that there is a concern. And we have over 1,000 policy documents published in the past year. Incidents and controversy repositories are showing that there is an exponential increase in harms and incidents. And there's many AI-related bills passed into law globally. But all of these focus on a set of problems that is not the problem that I'm talking about. They focus on bias in algorithms, so human bias, the fact that it is white men who have created the algorithm and their bias enters into it, spurious proxies, so there is an assumption that is made about someone to form the proxy that will be used to replace the data gap, biased labels, lack of proportional representation in data, or the data deserts that we hear about a lot. The issue is that even with all of these things addressed, even if by some absolute miracle we have full proportional representation of everybody in every data set, the majority will still outnumber the minority as long as we use statistical reasoning. And statistical reasoning as the means of making decisions does harm to the outliers. Assuming that what we know about the majority applies to the minority does harm to the outliers. And we call this statistical discrimination. AI determinations that are inaccurate or wrong for outliers, small minorities, or people excluded from data. And within AI suspicion systems, security, audit, defense, they do not recognize edges of data distribution and flag them as anomalies. One of the things we've worked with defense departments as well, which shows that the collateral damage of individuals who are unique or outlying or not fully recognized in defense systems is increasing as well. And this becomes cumulative and self-reinforcing. If you look at harm and incident databases, there are tons of examples. Parents with disabilities falsely flagged as unfit, false positive tax audits, excluded from optima filtering and employment, unfairly high insurance rates, deprioritization of it's end of the day, relevant information, and as I mentioned, iatrogenic death and illness. And privacy is also, of course, an issue because the privacy protections for this particular group, while they're most vulnerable to privacy abuse and misuse, all of the privacy protections don't work. And so what we actually need to do is to prevent abuse and misuse. Unfortunately, statistical discrimination enters in AI ethics tools as well. And we have an AI ethics industry that is giving certificates to AI applications to say that they're ethical. But these don't address this particular issue. Most of them use cluster analysis and comparison. They compare the performance with the general population with a particular protected group. For disability, there isn't any data cluster. The data is hugely diverse. And what we're finding is that this same pattern emerges there as well. And I'm told I have 4 minutes to go. It is also invisible in a risk-benefit framework. Most of these hugely harmful things are flagged as a minority or as an anomaly, merely an anecdote. We don't need to worry about them. We don't need to do anything about it. So what we've worked on, or what we are in the process of taking through committee, is a draft standard, which is called the Accessible and Equitable Artificial Intelligence Systems Standard of the Accessible Canada Act. And it's a phased approach where first we're addressing automated decision systems and then large language models. It's specific to disability, but it will apply to anyone who's an outlier or a small minority within a data set. And there are 4 parts: accessible AI, which ensures that anyone can participate in the entire AI ecosystem, so that people with disabilities are not just consumers of AI consumer products, but are also helping to design, develop, deploy, evaluate them. And then equitable AI is about equitable decisions about people who are outliers and small minorities within AI systems. And then there's an organizational processes that support accessible and equitable AI. And lastly, education, both that education about AI includes education about equitable and accessible AI, that people with disabilities can actually access education about AI, and that AI learns from the incidents, the complaints, and the issues that people have with AI. And I'm going to very quickly. So we have multiple approaches that we're also trying within WeCount, inverting the way that decisions are made using data, such that, for example, with an employment AI, the system tries to find people who are different, culture add as opposed to culture fit. So that you don't create a monoculture within your work environment, but rather you increase the diversity and the diversity of perspectives, which we all know results in far greater innovation and a much more resilient workplace. We are doing things like creating trust meters, where it tells someone that's deploying AI to make a decision that the person in front of them is not, this system will not work as a decision for them. And so, in conclusion, we've determined that intelligence that works with the edge of our human scatterplot is better able to adapt to change and respond to the unexpected, detect risk, transfer to new contexts, results in greater dynamic resilience and longevity, will reduce disparity, and to some extent may hold the key to our survival. And I need to make the following acknowledgement that we've been supported by Accessibility Standards Canada. And these are my contacts. Oh, and I think I started 5 minutes late, so is there any questions? Yeah, there's time for a question. No questions?
I don't feel worthy to ask this question. It might be silly.
No silly questions.
Okay. So I noticed, from the 2000s to 2010, how web accessibility and web access and user interfaces, there was like a homogeneous collection. Like,
yeah.
The difference between human experience and human expectation, the attenuation that we have towards an experience. My question, if I can frame it right, is basically in that human scattered diagram, the more that we address the 80% and the more they cluster in the center, does that not, in some cases, make it easier to address the anomalies?
No, because what we're doing is we're reducing the choices, right? The people that are in that clustered in the middle, in that 20%, only require a certain amount of features. And so the system becomes less resilient because the environment changes, interoperability system, I mean, the system becomes more entangled and complex. So the more we only focus on those 80%, it isn't of benefit to anyone. It's certainly not of benefit to people who are thereby excluded. One of the things, I mean, often a question that accompanies that is the cost question. Well, you know, who do we, if people are so diverse, there's so many different people that we need to design for, what happens to cost. But what we actually did was we did an economic modeling study with a number of services that either designed with the entire spread right from the beginning versus just for that 80% largest customer base. And what you find is that as if you only design for that 80%, there are going to be many requests for changes, feature additions. Help will be, the amount of help that you have to provide, the amount of fixes and patches you have to do will increase. And so you become very brittle and end of life happens. So, but if you design for that entire spread, then right from the beginning, it may take a little bit more time, it may take a little bit more money initially, but in the medium and long term, you become much more adaptive and resilient, and you save money in the midterm.
Thank you.
I'm going to ask for some validation. That's kind of what this question is. So when I approached my build around setting up a whole data services platform from end to end, one of the things that I really focused on was creating more service design and focusing on outliers and creating composable architectures. And I'm hearing more and more transition into that space, particularly from public sector bodies, both at the municipal level, at the provincial level, and at the federal level. It takes more time to do the upfront work. It takes more time to understand the permutations and who is sitting on the edges of your computing architecture, who is sitting in the edges of the framework, but it also builds in equity and allows you to create or try to remove some of the bias from the way we collect data, from the systemic bias that already exists. So for someone who's already on this journey, can you highlight any pitfalls that might come up or anything we should be really vigilant about moving forward?
Yeah, so we use a nonlinear logic model. I think the notion of a solution, a fix, that you're done is a pitfall, because you're never done, right? Everything is changing all the time, and any design decision it will therefore need to be adjusted. And so our logic model is what we call a virtuous tornado. You're starting right from the beginning to try to create a system that will be adaptable and that will have sufficient flexibility that as new requirements emerge, whether they're from people or from interoperable other systems or some sort of disruptive thing that happens in the world, you'll be able to change. But yes, I mean, I validate that's great that you're asking the people that face the greatest barriers. And you need very few of those people that face the greatest barriers, because once you have one barrier, you're likely to have many barriers. And so where you might need hundreds of people to verify your design, if they're in that complacent middle, they're very similar to each other. They have very little innovation that they need because they're already doing well. But if you have just a few people that experience the greatest barriers, then you get a huge, rich set of data as to how you can improve things and what might go wrong. Okay.
I've got a question over here. Is there any initiatives or projects, tools that like get you excited of a good example of like a group or especially a third party developed that's getting it right that you could direct as a case study or something that you get excited about in supporting all inclusivity in the solutions that we make?
Yeah, we have quite a number of people that we're working with. So one, the hiring example that I gave is out of Stanford, and it's Danielle Lee, and they're looking at exploration bandit algorithms for hiring tools. I was actually challenged by Wendy Chun, who is at UBC, in the Data Fluencies project to tell her how I would do it differently, and specifically large language models. And so we're doing a community data, we call it the Baby Bliss Bot, because it's looking at creating a chat bot that is created by the community using the language with the community, and it's intended to be for creating chatbots that will recognize and teach endangered languages or precarious languages. I can list lots more. There's quite a few, and the validation that comes from these success stories is growing, in addition to the harm and incident databases that are growing. But I can tell you more if you email me. I think I'm way out of time.